All right, this is the first lesson on the next topic, which is thermodynamics. We're going to look at energy and heat in this chapter, or I'm sorry, in this video lesson. This is one component of a big topic called thermodynamics. We're going to cover thermodynamics in two sections. In this section, we're going to look at mostly thermochemistry. So this is a lot of... All right, so thermodynamics is looking at heat and how we can use heat to generate power. Very important topic for our civilization, because we basically thrive and live off of heat. So we heat our homes, we cook our food, we run our cars, we do a lot of stuff with this thing called heat. I'm not going to go into too much here. I'm just going to get right into the material. So thermochemistry is really looking at the relationship between chemical reactions and energy transformations. In this case, chemical reactions and heat. So like I said, we're going to be focusing on heat quite a bit in this unit. Okay, so from physics, you should remember that energy is essentially capacity to do work and produce heat. I'm not going to go into much on this. You should know kinetic energy and potential energy. But as I said before, we're gonna get rid of this idea of work and focus solely on heat. Okay, so let's get into the chemistry. All right, so if we're going to talk about energy and energy transfers, that's the thing that's confusing about this topic, is where is the heat and where is the heat going is kind of the idea. So we're going to start with defining two things. One is known as our system, the other is known as the surroundings. Okay, so the universe is basically everything. But what we're going to do is we're going to focus solely on what's called the system. That's the part of the universe that we're looking at and experimenting with. The surroundings is pretty much the rest of the universe. So for us in chemistry, our chemical reactions, things like water being produced by hydrogen and oxygen, would be an example of a chemical system that we would be looking at. Okay, so we'd be looking at this system. We want to know as these reactants convert to products. So essentially our system in chemistry are the reactants and our products. That's really what our system is in chemistry. It's a little abstract. It's not like clear cut sometimes, but just keep that in mind, that we're looking at reactants converting to products. So our system is something that's actually undergoing a change, and that's good because that's where the energy is going to come from. So reactions are going to give up energy or they're going to lose energy. So systems are going to lose heat or they're going to gain heat. I'll talk about that in a second. And it's really important that we keep in mind the point of view. It's what POV stands for. We typically take the point of view of the system. So we are always going to put ourselves in the perspective of the system. And I'll show you in this next slide why that's important. So if we talk about systems, you should know that there's two terms, exo and endothermic processes. So if this is our system, let's say there's a chemical reaction inside of here that's taking place in this flask. Well, we would think of that chemical system as really the system that we're looking at, and everything else, the flask, everything else. Here they're saying the flask and the contents, really it's more of the contents than it is the flask. Anyway, so let's say heat comes out of this. Well, that heat has got to go into the surroundings, right? It's got to go from the system to the surroundings. So that's what we would consider an exothermic process, because we're taking the perspective of the system, and our system is losing heat. Heat is coming out of our system. So if we are the system, we are losing heat. We would say that that was negative. From the perspective of the surroundings, we are absorbing heat. So if we were witnessing the same process, but we were now the surroundings, we would experience energy being added to us, and we would say that that is positive. So it's important that we know which way that we're talking. So if energy is going into the system from the surroundings, going into the system, we would say that that's endothermic. Energy is going into it. We would put that as a plus sign because according to the system, we're gaining that energy. Okay, for the first one, we would say that that was negative, that we would be losing energy because we're taking the perspective for both of those processes as the system. I know it's a little confusing, but you really have to make sure that if you know that the system is negative, the surroundings are positive. Now, we're going to look at what's called the first law of thermodynamics real soon. And what that means is that this box is the universe, right? This little box is the universe. So that heat has to go into the universe, the rest of the universe, that is the surroundings. So whatever the magnitude is of the system, the surroundings would be opposite that. So these two would always cancel out. So the energy of the universe is always going to stay constant. That is one of the very fundamental ideas of thermodynamics. And we're going to talk about 3 laws of thermodynamics by the time we're done here. Okay, so let's take a look at work and heat. Actually, let's not look at work. We're going to actually drop this part out. We're not going to be focusing on work in this class. We're going to focus solely on heat. Now our change in energy of our system, so that's what we need to look at next, is our system's energy. Okay, we're going to talk only about heat. So there's two ways that energy can be transferred: through work and through heat. We're going to get rid of the work part, focusing all of our energy on heat transfers that are going to go on. Okay, because if you look at the gas escaping, then you would incorporate the work, and we're just not going to do that. So what we have here is what's called the change in internal energy. E is going to be what's called internal energy. Okay, so let's look at internal energy. Internal energy is the energy of the system. So if we were to look at that system, we would sum up all of the potential and kinetic energy that's in that particular system, that chemical reaction. So what that means is we're looking at hydrogen reacting with oxygen. We would look at the energy of the hydrogen, the energy of the oxygen, potential and kinetic energy, so the motion of the particles. We would look inside the atoms and the molecules, and it just gets really crazy. The idea is that internal energies themselves are really hard to figure out. We can't really measure that. What we do is we measure changes in energy. This is kind of an important concept if you think about energy. We don't see energy. We don't feel energy. We feel the effects of changes in energy. So if I were to look at hydrogen and oxygen, there's energy in that system, and then there's energy in the water. All right, that's the idea. That would be my initial, would be my reactants. Right? So we would really say that these are reactants, and for us in chemistry, these would be products. Right? So that would be our initial and final in chemistry. So we're looking at how much energy does this have in relation to the initial. So if this is my reactants and products, what is that change in energy? So we know that if we take hydrogen and react it with oxygen, there's going to be a certain amount of energy in that system. Okay? When we produce the water, that energy is now lower. So this change, this difference between these two levels here, this change in energy between our initial and our final, is what we call the change in energy, and that's what we're going to call heat. We're going to change it from change in energy in just a little bit to change in enthalpy. Okay, so that would be heat. Okay, that's where our heat is coming from, the fact that our reactants have more energy than our products do. So change in internal energy is going to be equal to Q plus W. We're going to drop the W part out, so we're really just focusing on changes in internal energy via heat. Okay, so that pretty much wraps up this concept right now. So in the next video, I'm going to get into this idea of enthalpy and what we're going to do with enthalpy and thermochemical equations. So I'll talk to you later. Bye.